Hi everyone, welcome to our first lesson in 3.3 notes. So 3.3 has been broken into two parts, and the first part is on angles of elevation and depression, which is what we're going to look at right now. And the second part of 3.3 is on putting all of our knowledge together about right triangles and solving everything in a right triangle. So we're going to do that lesson separately. So right now we're just looking at angles of elevation and angles of depression. So let's go ahead and get started. Elevation and depression refers to looking up at something. So an angle of elevation is to be elevated means to go up, and depression is when we're looking down at an object. So if we're up in the sky or on a roof looking down at something on the ground. And these are actually just special cases of right triangles, but we need to be familiar with the words angle of elevation, angle of depression. So what I'm going to do here is draw a diagram. Let's put some labels on our diagram. And the first thing I'm going to do is draw a horizontal line, which we've actually already got here on our diagram. Okay, and imagining that that is a lower horizontal, which could be the ground. Okay, so we've got a horizontal line here, which could be the ground. And if we draw another upper horizontal line, so that runs parallel with the line below, okay, that could be a line in the sky, for example. Okay, but it's just a line that runs parallel to a lower horizontal line. If I'm standing on the ground, looking up at something in the sky, so if you imagine that I'm standing right here, okay, let's say I'm looking up at something in the sky. Maybe it's a plane. So I'll try to draw a plane here in the sky. Okay. The line of sight would be between me, my location, my eyeball, and the thing I'm looking at. So it's an imaginary line of sight. Imagine that you had, laser beams in your eyes, and whatever you were looking at, you could see that line. That's what it would look like. So the line of sight is formed between where I'm standing and the object that I'm looking at in the sky. An angle of elevation is the angle that's formed when we're looking up at something. So when a person looks at something above, okay, his or her location. So when they're standing on the ground and they're looking, if their eyeball is here, okay, they're looking at something above, this is called the angle of elevation. And on our diagram, it is going to be the angle between the line of sight, which is our diagonal line, and the lower horizontal line, or in other words, the ground. Okay, so this is our angle of elevation right here. And the angle of elevation is pretty straightforward. Okay, it's between the ground where we're standing and the line of sight to the object that we're looking up at. That's the angle that it makes. The angle of depression is a slightly different. It's a little bit more complicated because if we're looking down at something, so if I was, for example, a person in the plane up here, and I was looking down at the person below me, okay, the line of sight is the same. However, the angle of depression is formed between the line of sight and an upper horizontal line. Okay, so this right here is the angle of depression. So an angle of depression or elevation is always between the line of sight and a horizontal. Okay, so in the case of an angle of depression, it's the angle formed between the line of sight and an upper horizontal line. So it could be a line in the sky, for example. Okay, and the angle is going to be the angle that's formed right in between those two. Okay, and an angle of depression is when a person is looking at something below his or her location. Okay, so to draw a quick little diagram for us here, if somebody is up here, okay, I'll draw their eyeball, and they're looking down at something, the angle of depression is not the angle that's made. You might be tempted to make a little vertical line here. That's the angle of depression is not between the vertical and the line of sight. Okay, it is between the horizontal and the line of sight. So it is right here, angle of depression. And there's some interesting things that are always going to be true about an angle of depression and angle of elevation. So on your next page, it says a right triangle can be formed, okay, in these problems because we have two horizontal lines, a vertical line, and a line of sight. And so if we actually can get two right triangles out of this, but generally most diagrams will give us at least one right triangle. So we have a horizontal line here. Okay. We have another horizontal line here. Okay, our line of sight is the diagonal line. This is, in math, we call a line that intersects two horizontal lines. We actually call it something called a transversal line. Okay, in other words, it intersects two parallel lines. That's called a transversal. For Math 10, we're just going to refer to that as our diagonal line, okay, or our line of sight here. Okay, but just for your information, this is called a transversal. That's a line that intersects two parallel lines. And if you do Math 11, you'll deal with this term, transversal. We can connect the two horizontal lines anywhere here, okay, with a vertical line. So there's a vertical line. Okay, which gives us a right triangle down below. There's a 90-degree angle between the horizontal and the vertical line. Okay, and our angle of elevation is right here. There's our angle of elevation. And up above, if I were to connect this horizontal line above with the horizontal line below, sorry, with the one directly above it, I get another right triangle right here. Okay, up above. And the angle of depression is right here between the horizontal line and the line of sight. So there's my angle of depression. Okay, right there. So a couple of things are going to be true. One thing that's true is that a diagonal line, okay, or a transversal, that intersects two parallel lines, the angles that are formed, okay, the alternate angles, so this angle right here, the angle of depression, and the angle of elevation are the same. So the angle of elevation equals the angle of depression. This is always true. Okay, always true. So those two angles are equal. The other thing that's always true here is that the angle of depression, okay, and this vertical line here, or I should say the horizontal vertical line, make a 90-degree angle. And so the angle of depression plus this other missing angle, let's call it beta. So this missing angle here, well, the angle of depression and that missing angle have to equal 90 degrees because they make up a 90-degree angle. It's also true that this angle, missing angle beta, is part of a right triangle. And that right triangle, I know, has a 90-degree angle already, plus an angle of elevation. Okay, so the angle of elevation and the missing angle together have to equal the other 90 degrees of that triangle. So the missing angle here is going to be equal to, so beta is equal to 90 degrees minus the angle of, I could say minus theta, or minus the angle of elevation or depression, because they are actually the exact same value. So I can always find that missing angle. Okay. One other thing that's true here is that that angle beta, okay, is equal to this angle over here as well, between the other vertical and the line of sight. So those two angles are the same. Okay, we have another right triangle on the other side here. So something that we can do for ourselves is draw a quick a quick summary. Okay, so whenever we have a diagonal line that intersects two horizontal parallel lines, okay, if I have two horizontal lines like this, and I have a diagonal line that intersects them, okay, just like that. If I connect the two horizontal lines with a vertical line in order to make a rectangle, okay, what I have here is two right triangles, or a rectangle, and each corner of the rectangle is equal to 90 degrees. Okay, that's true, always for a rectangle. And what I have here is a couple of statements that are going to be true. So the angle of elevation, we'll call it theta, is equal to the angle of depression. Those two angles are always going to be equal. These are called alternate interior angles. And they're always equal. They form as a backward Z, or actually a forward Z, and they're always going to be equal. The other thing that's true is this angle here, let's call it beta, is going to be equal to the angle that's alternate from it. So over here, this angle right over here. Okay, it forms and also a Z on its side, and those two angles there are going to be equal. Okay, so that's always going to be true. And together, the angle of elevation plus beta equals 90 degrees, and so does the angle of depression plus beta. They also equal 90 degrees. So theta plus beta together equal 90 degrees. Okay, so this is a quick summary. Let's put this to some use now and actually do some real examples. Okay, what we're going to find is that we actually just get special cases of right triangles where we have to use the sine ratio, the cosine, or the tan ratio to solve for some part of that right triangle. The trick here is just recognizing when we see the word angle of elevation, what is it talking about? Can we label it? So let's go ahead and do the first example. It says, a bird watcher sets up a camera on the ground and it points to the top of a tree. The tree is 10 meters tall and the camera is set up 50 meters from the base of the tree. What is the angle of elevation? I have a diagram given to me, but if I didn't, you could also go ahead and draw yourself a diagram. Okay, it might look something like this if I drew it to the side. I have a tree. Sorry, I have a tree here. Okay, well, I know a tree stands vertically tall. I know this tree is not lying on the ground because it doesn't tell me that it's on the ground. So I assume it's standing straight up. Okay, there's my tree. And take the information that you have. The tree is 10 meters tall. Okay, well, tall means vertical, so there's my tree, and it's 10 meters. So we have a diagram here, but just in case, I want to show you how you make one. Okay, the other thing I know is that I have a camera, and it's set up 15 meters from the base of the tree. So it's on the ground, the camera, and it's 15 meters away from the bottom of the tree. Okay, I could have drawn the 50 meters in the other direction. It doesn't make a difference. You're still going to get a right triangle. Okay, so here's my camera right here. So coming over to my diagram here, there's my camera. Okay, 15 meters away from the base. The camera is pointing up at the top of a tree. Okay, so if I could draw my line of sight from the camera up to the top of the tree, that's my line of sight. It doesn't tell me what distance that is. Okay, but I know that's where it would be. So what I actually have then is a right triangle. What is my right angle right there? And so I'm asked, what is the angle of elevation? Okay, well, which of these angles, I know it's not the 90-degree angle, but which of the other two angles is the angle of elevation? Well, let's come back here and remind ourselves what that means. The angle of elevation is between, okay, the line of sight, always, and the ground, or the lower horizontal line. So whenever you draw a diagram, okay, you can, if you have a lower horizontal line, which might be the ground, maybe it's water, depends on your question. That lower horizontal, and the line of sight is going to be the two lines that make your angle of elevation. So in other words, the angle of elevation is right here, okay, between the camera, with the camera sitting, and the ground and the top of that tree. Okay, there's my angle of elevation. So the angle looking up. So this question is asking us to find that angle. Okay, so what I'm going to do is if I drew a diagram over here, I'm going to draw a nice simple right triangle out of my diagram, and I'm going to label it, and I have to think about what angle am I going to be looking for or using, and it is this angle right here, the angle of elevation. So we're going to label the triangle, okay, relative to the angle of elevation. So in other words, the angle of elevation is my angle of interest. So let's label the triangle using that angle as my angle of interest. So the opposite side will be the side opposite from that angle. So it's the tree. 10 meters is the opposite. Hypotenuse is always the side of the triangle that's opposite from the right angle. So there's the hypotenuse there, okay, across from the right angle, which makes my leftover side the adjacent side. Okay, and let's use green for that. Okay, so 15 meters is my adjacent side there. It's really important that I label my triangle correctly. Now I'm looking for theta. So I want theta. I want the angle. Let's see, what do I have? Well, I have 10 meters. That's the opposite side. Okay, I also have the 15 meters, which is the adjacent side. So if we come over here and think of the three trig ratios that we have, so, ka, toa, let's, process of elimination, figure out what the one that I need is. Okay, opposite and adjacent are what I have. So I have opposite and adjacent, which means I'm going to use the tan. Okay, a good way to rule this out is if you look at the triangle that you have, the only one that you don't know is the hypotenuse. So I have to have two pieces of information here to solve. Any time I'm doing a question, I have to have two pieces of information. So if I don't have hypotenuse, that means I can't use the sine and I can't use the cos because they both require me to have the hypotenuse. So what I'm going to use is the tan of theta, so the tan of the angle, is equal to the opposite over the adjacent. So the opposite side is equal to 10 meters, and the adjacent side is equal to 15 meters. My meters are going to cancel because a meter divided by a meter is just 1. And 10 divided by 15 is 0.67. So I now have that the tan of theta equals 0.67. I want to know the angle theta, not the ratio. So anytime I'm finding an angle, I'm going to take the inverse of the ratio. So I'm going to take the inverse tan of 0.67. I always use the inverse when I'm looking for an angle. So my calculator, I say shift tan 0.67, and the angle comes out to be 33.7 degrees, and that is my answer. So my angle of elevation is 33.7. So if I come back here to my diagram, this is 33.7 degrees. Remember your angle that if you're looking for an angle, that's what you're solving for, you're always going to be in degrees with your final answer there. Okay, let's try another question where we have the angle of depression instead. So on the next page of your notes, you have second example, and it says a boat is 75 meters from the base of a lighthouse. The angle of elevation from the boat to the top of the lighthouse is 39.1 degrees. Again, start with a diagram if you're not given one, and use some common sense. A lighthouse, okay, stands tall, right? A lighthouse stands vertically. Okay, so this is going to be a vertical structure here. Okay, vertical lighthouse. So I could I have the beginning of a diagram here. So that could be my lighthouse right here. Okay. There's the light. Okay, and this would be the top of my lighthouse then. It would be right there. Okay, and I know that, does it tell me the height? No, it doesn't. So I just know that my lighthouse would be standing vertically. And then it says that a boat is 75 meters from the base, which is the bottom of the lighthouse. So there's the bottom of my lighthouse, and 75 meters away is a boat. Okay, so my lighthouse would be, usually your lighthouse is out on the water. Okay, so this is my water here. Okay, and 75 meters away from the base right there is a boat. So let's go ahead and draw our boat. Okay, 75 meters away. I could put my right angle in right now because I realized that a vertical line and a horizontal line are going to make a right angle. Okay, so this is my horizontal line, the water. Okay, then it says that the boat, if the boat is looking up to the top of the lighthouse, so from the boat to the top of the lighthouse, the angle of elevation is 39.1. Well, there would be the line of sight between the boat to the lighthouse. And the angle of elevation is between the line of sight and the lower horizontal line. So there's my 39.1 degrees. Okay, 39.1. This is my angle of elevation. Okay. What is the angle of depression is the question, the first part. First of all, an angle of depression is between the line of sight and an upper horizontal line. All right, so up at the top of my lighthouse, I could just take my ruler and draw a line that's parallel to the water, and that would be an upper horizontal line. Okay, it's important to do that because that tells me then that the angle of depression is going to be between that upper horizontal line and the line of sight. So there's the angle of depression right there. Okay, that's my angle of depression. And an angle of depression is equal to the angle of elevation. This is true because anytime you have two parallel lines and a diagonal line intersecting them, the angles that are alternate from each other are equal. So this is also 39.1 degrees. And that's my answer, 39.1 degrees. Okay, what is the angle formed between the lighthouse and the line of sight? Well, what is that asking me? There's the line of sight there. There's my lighthouse. It's a vertical line. Okay, so it's asking me what is this angle right here? Let's call it beta. Okay, what is that angle? Well, there's two ways you could solve this. One way is that you can recognize that you have a right triangle down below. And so there's two methods here. Okay, one method is that beta is going to be equal to 180 degrees minus all the other angles that you know in that right triangle. So minus 39.1 degrees, angle of elevation, and minus 90 degrees for the right angle. And that's going to give us 50.9 as our answer. Okay. The other method that you could have used to solve this is if you look up at your diagram for a moment, angle beta that I've just named here and 39.1 angle of depression together make a 90-degree angle. So another way I could have solved this is that 90 degrees minus 39.1 degrees will give me that missing angle. Okay, and that's going to be the exact same thing, 50.9 degrees. So that's my answer. Okay, finally, the last part of this question says, how tall is the lighthouse to the nearest meter? What I'm looking for now is this right here. How tall? as that lighthouse. At this point, you have a lot of information on your diagram. I would draw a new triangle for ourselves, okay, that looks like this. Same thing, but with a little bit less less writing, okay? And I'm looking for this right here. Let's call it X, because that's the height of the lighthouse. Okay, that's what I want to know. And I know that down below, okay, the bottom of my triangle here is 75 meters. And I have this angle, 39.1 degrees. That's the angle of elevation. You also have the angle of beta, which is 50.9. And so you could also use that angle. You've got more than one way to solve this problem. Okay, I'm just going to use the angle of elevation that I was given originally to solve it. I'm going to put my right angle right there in my triangle. Okay, and now what I'm going to do is label my triangle relative to my angle of elevation. So I'm going to use angle of elevation, okay, as my angle of interest, which means I'm going to label my triangle relative to that angle. Okay, so let's make this our angle that we're going to be using. And that means that the side opposite from it is the height of my lighthouse. That's what I'm looking for, X. The other thing I can immediately label is the hypotenuse, which is across from the right angle. There's the hypotenuse. And that means that the leftover side, which is 75 meters, is my adjacent side. Okay, so what am I looking for? I'm looking for opposite, which is X. So I want opposite. Okay, I have an angle. And I also have the adjacent. So if you go to your three trig ratios, so ka, toa, right away we know that we're looking for the opposite. So I need to be using a trig ratio that has the opposite side in it. So that leaves me with so or toa, so sine or tan. I'm not going to be using cosine here because if I use it, it's not going to give me the opposite side, which is what I need. The second thing I have to do is decide whether I'm going to use sine or tan. Well, I have the adjacent, so I have A, okay, which means that I'm going to use the tan because I have A and I want the opposite. If I use sine, it will give me the hypotenuse. Actually, sorry, I can't use sine because I want the opposite and I want the hypotenuse, so I don't have anything here except the angle. So I certainly can't use sine. Okay, so my only option here is to use the tangent. Okay, if I'm using 39.1 as my angle. Okay, so let's go ahead and solve this. Let's start with the tan of 39.1 degrees equals opposite over adjacent. Well, opposite is what I want, so we're going to call that one X because that's how I've labeled it here. And adjacent is 75 meters. Okay, well, all that's left to do now is get rid of that 75 meters on the bottom. You can either cross multiply to get it up to the top, or you can just times each side by 75 meters to get rid of the 75 meters on the bottom. And we have X is equal to tan of 39.1 times 75. And my answer is going to come out to X is equal to, let me write it right over here. Sorry, folks, I'm running out of space a bit for you. Oopsies. Apologize. Let me just come up here for you. I'll just write that again, okay? Okay, and my answer is going to be, well, the tan of 39.1 gives me 0.81267 times 75. Okay, I get 60.95 is equal to X. So that answer X is actually, this is a side. So that is the height of my lighthouse. So X, okay, is the height of my lighthouse, and that is equal to, if I round it to the nearest meter, it's going to be 61 meters. So I could go back to my diagram there and write that right there. 61 meters is my opposite, that's my x. And I could put that in my original diagram as well. And I've solved it. Okay, I'm going to do one last example that's a little bit more tricky. And let's go ahead and have a look at something where we have to think a bit about the diagram that we're making. So this next example says find the angle of elevation. And here's the scenario. It says a person stands 1.7 meters above the ground. Okay, so above, vertically off the ground. Maybe they're standing on a ladder. And the person is looking at the top of a tree, which is 27.5 meters away from where they are on level ground. Okay, the tree is 18.6 meters high. Find the angle of elevation. Let's start off by drawing ourselves a diagram. Okay, so that's the first thing I need to do. Okay, let's break it down piece by piece. The person stands 1.7 meters above the ground. So let's draw the ground first of all. Ground is a horizontal line. Okay, and the person is standing 1.7 meters. So here's the person standing above the ground, 1.7 meters above the ground. Okay, and they're looking at the top of a tree. The tree is 27.5 meters away on level ground. So the tree, if the tree is over here, let's go ahead and draw our tree. I'm going to draw a slightly taller tree just to give us a nice big triangle here. Okay, there's my tree. And the distance from the person to the tree on the ground is 27.5 meters. Okay, from the bottom of the tree to where they're standing. And the person is looking at the tree, at the top of the tree. So the line of sight is going to be between this person right here. Okay, so we'll draw it from where they're standing, so right there. Okay, to the top of the tree. So there's our line of sight right there. Okay, and finally what I know about the tree is that it is equal to, let's go ahead and draw in a vertical line right there. So the tree, okay, has a height of 18.6 meters. So that's the last piece of information that I'm given. So that's the vertical distance from the bottom of the tree to the top of the tree, 18.6 meters. This is a slightly more challenging question because the person isn't standing on the ground. So if you look at this, right now, this does not actually make a triangle yet. It makes a four-sided shape, okay, because of this little 1.7, this part right here, okay. But if I connected where the person is standing right here, if I brought this horizontal line over, okay, in other words, I drew another horizontal line that was parallel to the ground, I would have a right triangle. So I have a slightly smaller right triangle here. Okay, there's my right angle, just like this was a right angle down below. And now I have a right triangle that I can work with. Okay, so this is just another horizontal line that I've drawn in. And I am going to need that because I'm asked for the angle of elevation, and that's the angle between the line of sight and the lower horizontal. So I have to put a horizontal line in there. And I'm looking for this angle now, the angle of elevation. Okay, that's what I want. So that's my angle of elevation. Before I can start this question, I recognize that when I drew that new horizontal line over, that made this distance here in my right triangle smaller. this vertical distance here is now not the whole height of the tree. It's not equal to 18.6 anymore. It's smaller than that. And so I have to find, what is that height now? What is this distance right here? Okay, well, this distance here, which is going to be the opposite side, opposite my angle of interest, this side over here is now going to be equal to, so we'll call this, okay, this is the new side. It's equal to 18.6, okay, minus this little 1.7 distance here. So this distance right here is 1.7. Okay, because over here it was 1.7, and this is the line I made is it's just a horizontal line, so it's the same distance over here. So it's minus 1.7. So I can figure out what is that new side, and it's equal to 16.9 meters. Okay, so now that new vertical height in my right triangle is 16.9 meters, and that's important. Okay, let's figure out what is the angle of elevation. Well, the angle I'm looking for is this angle right here. So I'm going to label my triangle. Okay, we're going to label our right triangle. Okay, relative to that angle, okay, which is the angle of elevation. So let's go ahead and label the opposite side, the adjacent side. Okay, being careful when we do that. So the side that's opposite from my angle of elevation is over here. So this 16.9 is my opposite side. Hypotenuse is always the side of the triangle that's across from the right angle, which is the line of sight. Okay. And the leftover side is the adjacent side, which is this horizontal line right here. Okay. There's my adjacent side. And I know that the adjacent side has the same distance, okay, as before from the bottom of the tree to below where the person was standing. So it's still equal to 27.5 meters. Okay, so now I can go ahead and solve for theta. So I'm looking for theta, or I'm looking for my angle of elevation. Okay, and let's think about what I have. I have, if you look at your diagram, I have the adjacent side and I have the opposite side. Okay, so using my SOHCAHTOA, there's my three trig ratios. Let's see, I have A, so, okay, I could use, so far I could use cos or I could use tan, so that gets rid of sine. Okay, the other thing I have is O, so that right away process of elimination tells me I have to use the tangent ratio because I can't use the cosine ratio because I only have A, I don't have H. Okay, so I have to use the tan of theta is equal to the opposite over the adjacent. Okay, so let's go ahead and do that. The tan of theta, I don't know theta, it's what I'm looking for, but I have opposite and I have adjacent. So opposite is equal to 16.9. Write that in, 16.9 meters over the adjacent, which is 27.5 meters. Those meters are going to cancel and give us just 1. And what we get is 16.9 divided by 27.5 is 0.6145. Okay, so the tan of theta equals 0.6145. I want to know what is the angle theta, so I have to take the inverse tan. Remember, every time we're looking for an angle, we take the inverse trig ratio. So it's going to be the inverse tan of 0.6145. Okay, and when I do that on my calculator, it gives me 31.6. And that answer is an angle, it's in degrees. And that is my final answer, 31.6. Great work. Okay, so the key for all of these questions is to figure out what you have from your question, what information you're given, the side lengths or the possible angles, and then draw yourself a diagram if one is not given to you, and then correctly recognize what trig ratio you need to use to solve the problem. In our notes, we have two more examples. I am going to skip them because we've already done, I think, enough examples to get you started here. So if you could just cross those out for yourselves, I'm going to skip those. If you're really interested in it, I will post the key to these so you can have a look or try them yourself, and then you can check your answers by looking at the notes. But for now, I think that we'll keep this lesson a little bit shorter. And I want to just quickly summarize them, that when we're looking at questions that involve angles of elevation or depression, they're just really, they're just right triangle questions. They're not any different than anything else that we do in this chapter. But we do want to be able to recognize what the angle of elevation means and what the angle of depression means. There's more than one way to solve a problem. So we didn't do this last example, but when you're looking at any right triangle, you may have a choice of angles, okay, that you're going to use. And so you may have more than one trig ratio that you can use. But how to solve these problems, you know, it's always the same. Start with a diagram, which is going to end up being a right triangle. So find the right triangle in your question. Fill in all the values that you know. So if you know any side lengths, you fill them in. Okay, any angles, you fill them in. Then decide what you're looking for. Okay, choose an angle that's going to be the angle of interest, and then label the rest of that triangle relative to that angle. So you know, the opposite side and the adjacent side and the hypotenuse, mainly the opposite and adjacent here, because the hypotenuse is always going to be across from your right angle. But your opposite has to be across from the angle that you've chosen. Okay, and the adjacent will be the other side. Okay, then once you put all that information in, you're going to have an option here of which trig ratio to use. You may only have one choice. If you have more than one angle, okay, you might have more than one choice here. But again, label your triangle first, and then you will be able to see clearly which trig ratio to use. Okay, I'm going to get you to try on page 132 questions 4, 6, 8, and 10. Check your answers in the back of your textbook to see that you're doing it correctly. And good luck. Thanks for joining me. Bye for now.